Okay, so for my first sort of like question, my first applied question, I've actually chosen something which hopefully you can all see would be easy to prove just by using standard algebraic means, okay? So we're given that n must be even. We could just swap it for a 2m and then just swap the n's for a 2m and then show that 4 is a factor. But the reason why I've chosen this question is because I kind of want to demonstrate induction, okay? Because induction is a topic that can really confuse people, okay? So let's start. So the first thing we do for induction, the very first step, is we say, well, look, let's see if this is indeed true for the smallest possible number that satisfies the conditions placed on the question. So what I mean by that is it says n must be even. The smallest number that's even is 2. So all I'm going to do is I'm going to substitute 2 into this equation, into this expression, okay? So if n is 2, then the expression becomes 2 times 2 plus 2, which is 8. Okay, so good, great, it works. All right. Part 2, I'm going to think of n as being a class of numbers, and I should say a finite set of numbers, such that I'm basically going to put every single number that I could possibly substitute into this that satisfies this condition in this group. So what I mean by that is I've just checked that 2, whether or not 2 works. 2 actually does work. Okay. So what I could do now is I could try 4, and I could try 6, and I could try 8, and every single time I check, see if it works, and if it does, I pull it into this group, and I could just keep going forever, right? We could just expand this group on forever. But there is an easier way. Let's assume that this works for every single number up to k. Now, just to be clear, k could be 2, right? I mean, I've made it look as if this is a number greater than 2, but it doesn't need to be, all right? K could literally be 2, all right? So what I'm going to do is I'm going to say, well, look, this does work for k is 2. Sorry, for k, okay? So what I'm saying is, if I see the expression k plus 2, okay, then that would, whenever I see that, I know that's going to be in the 4 times table, as long as, obviously, k is a number in this list, okay? All right, so whenever I see that, definitely in the 4 times table. Right, so now I'm going to try something out. I'm going to say, well, okay, well, what about the next number? Which would be k plus 2 in this case, because it's even numbers only. So if k is even, then k plus 2 is the next even number. Well, okay, well, let's see what happens if I substitute that next number into here. I'm going to get k plus 2, k plus 4. All right, well, let's expand it out. So I've got k squared plus 2k plus 4k plus 8. All right, so now what I'm going to do, I'm just going to compare that to this, okay? And actually what I'm going to do is I'm going to divide this into 2 parts, okay? And you'll see why in a moment. Everything to the left of the dashed line, I'm going to factorize out k. And everything to the right, I'm going to factorize out 4. Okay. Now the reason why I've done that, there's actually 2 reasons why I've done this. The first reason is, if you ever look at this here, remember what I said on this line. If I see k plus 2, I know that that is in the 4 times table. And if you look at this other part, that is also in the 4 times table, which means that as I'm adding them together, this whole thing must be in the 4 times table. Now what that really means is, if I assume a finite number of numbers for which I can substitute into this, for this to be true, then I can always go 1 extra. So basically, what I'm trying to say is, if I assume k is 2, and that's it, all right, k can only be 2, can't be 4, can't be 6, can't be 8, this method actually says, actually no, I can bring the next one in. So if it's true for 2, it must be true for 4. If it's true for 4, it must be true for 6. If it's true for 6, it must be true for 8. Okay? So what induction does is it basically allows us to state something is true for a finite set of values, and then extend that to the next value, and therefore, if you repeat that over and over again, it becomes true for all values. Okay?